Hi, Assalamualaikum and a very good morning. So now we are still in chapter 1 matter, and now we're going to focus on the subtopic of 1.3 stoichiometry part 2 of the video. So in this video, we're going to learn on how to write and balance redox equation by using the Ion-electron method. In the previous video, we have learned about the determination of oxidation number and balancing chemical equation by inspection method. So if you haven't watched that one, please watch it now. In this video, we're going to focus on B2, which is in part 2 of the video. And in the next video, we're going to look into the learning objective of C and D in part 3. So without any further ado, let us start with part 2 of the video first. So the Ion-electron method, it focuses on balancing redox equation. So redox equation can happen in both acidic or basic media. And the balancing of redox equation involves three major steps. So they're going to be step number 1, divide the equation into half equation according to its respective species. Step number 2, balance the half equation for the oxidation and reduction processes. And what is meant by balance that is we need to ensure the number of atoms and the total charge on both sides are balanced. And for step number 3, we need to combine the two half equation in order to form a redox equation. So we have D, B, and C here. Okay, so D, B, C. And this happens, DBC happens in acidic condition. Okay, similarly, for basic condition, it will happen, we will follow the same step, which is DBC as well, but they're going to be an extra step, which is addition of hydroxide ion is added to the redox equation after we complete step number 3. So it's going to be OH here. Okay, and as for summary, for acidic medium, it's going to be DBC. For basic medium, it's going to be DBCO. Okay, so now let us focus on acidic medium first, which is DBC. So let's say you are in the acidic medium, and then we need to balance the given redox equation here. So we have ferrum 2 plus reacting with manganese 4 oxide, and it's going to produce Fe3 plus Mn2 plus. So first, we're going to follow D, B, C. So we're going to start with D first, divide. So we need to divide the equation into its respective species. So ferrum 2 plus with ferrum 3 plus. Okay, and we know that ferrum 2 plus to ferrum 3 plus is an oxidation processes because it's going to increase in oxidation number from +2 to +3. And then because we are talking about redox equation, when one equation is oxidation, the other needs to be a reduction. So it's going to be MnO4 minus reduced into Mn2 plus. Okay, one oxidation, one reduction. Okay, and if you are interested, you can also prove it. Like, how can you say that it undergo reduction? The best way to prove it is you need to find the oxidation number of manganese. How can we find the oxidation number of manganese? Okay, in order to find the oxidation number of manganese is the similar step as we have learned in the previous video. So let's say the oxidation number of manganese is to be X plus 4 oxygen, where the oxygen going to have a charge of -2, and then the charge of the molecule is -1. And hence, we can say that the charge of X, which is manganese, is +7. Okay, and hence the manganese will have a charge of 7 plus. And as what you can see, from manganese 7 plus, the oxidation number reduced into 2 plus. 7 into 2. So so you know that it undergo reduction, and this is how you will prove it. Okay, so we settle with divide. Now we're going to go to balance. So in order to balance the half reaction, let's say if you don't have a balanced oxygen atom, you need to add H2O. Okay, so this is statement number 1. If your hydrogen is unbalanced, you need to add H plus. Okay, this is statement number 2. Okay, and you need to also balance the charges. In order to do that, we need to add electron to the side with a greater overall positive charge. Okay, to understand more about this, let us look into balancing. Okay, so this is the two separate uh, half equation. So ferrum 2 plus to ferrum 3 plus, both have one ferrum, but the charge here is not balanced. So here we have plus 2, and here we have plus 3. Okay, in order to make sure the charge is balanced, we need to add electrons to the side with the greater overall positive charge. Okay, so for this case, we can add one electron because one electron refers to -1. So overall, it's going to become plus 2. So plus 2 and plus 2 is equal on both reactant side and the product side. Okay, and for the reduction, the same thing. You need to look at the atom first. One manganese, so no problem. But now on the, okay, let me put it here. This is one on both sides. Okay, oxygen, they have 4 on the reactant side. On this part, we have 0. And you need to read this statement. In order to balance the oxygen atom, we need to add H2O. So we need 4 of oxygen. And hence, we need to add plus 4 H2O here. Okay, let me put it nicely. Okay, we need to add 4 H2O. Okay, so the oxygen that we're going to have is 4. Right? But now our hydrogen on the product side gonna be 8. Okay, because 4H2. But this one doesn't have any hydrogen. In order to do that, we need to add H plus. How many should we add? Because we have 8 hydrogen on the product side, we need to add 8 H plus on the left hand side as well. Okay, so the number of atom is the same. Manganese on the left hand side, manganese on the right hand side, 4 oxygen, 8 hydrogen, and 8 hydrogen. Okay, so we have no problem with the atom. Now we're going to check the charge before we proceed. So for the charge here, you can see that the total charge here you have -1, and then here you have +8. So the overall charges here is +7. In here, this one refers to 0. So you only have +2. Okay, so +7 and +2. It is not balanced. So what you're going to do is you're going to add electron to the side with the greater overall positive charge. So you need to add electron here in order to reduce the number. So you need to, in order to make +7 to +2, we need to add 5 electron, because 5 electron means that we're going to -5, and hence the overall going to be +2. So the left hand side and the right hand side is the same. Okay, so now we're going to take this equation as well as this equation, and we need to go to the next step, which is step combine. Okay, so we need to combine the two half reaction, and we need to ensure that the two equations have the same number of electrons. We have to simplify where possible by cancelling species appearing on both sides of the equation. Okay, so this is from the previous step. So we have 1 and 2 here, but we need to ensure they have the same number of electrons. So we have 1 electron here, but here in the second half equation we have 5. So in order to make sure the number of electrons is the same, the equation 1 here we need to multiply by 5. Okay, so when we multiply by 5, we're going to get 5 ferrum 2 plus, 5 ferrum 3 plus, and 5 electron. Okay, so once we have the same number of electron, we can combine them. So the 5 electron on the product side will cancel out the 5 electron on the reactant side. And for the others, we just copy back again. Same goes to here. So on the reactant side, we're going to have 5 ferrum 2 plus, we have manganese O4 minus, we have 8H plus. We have arrow, and then we have a product side, which is 5 ferrum 3 plus. manganese 2 plus, and 4H2. Okay, so for the acidic medium, we have settled with divide, balance, and combine. Also, you can also double check the charges. So as what you can see here, the charges is 5 plus 3 plus is going to be 15. Plus 2, they're going to be plus 17. Okay, same goes to here. We have 5 times 2 plus 10, negative 1, and then 8 plus. So the overall charges here are going to be plus 17 as well. So it's going to be balanced on both sides. Okay, now we're going to move forward to the basic medium. So for the basic medium, we also going to use the step of DBC, but an extra step. Oh, okay. So the similar step as what we have learned, we need to divide the equation first. Okay, as what you can see in the equation, we have CrOH3 plus IO3 minus plus OH minus in order to produce CrO3 2 minus plus I minus plus water. Okay, the OH minus here refers to a basic medium, so you can ignore that, and the H2O can also be ignored because it is in the solution containing basic medium. Okay, and now you're going to divide the equation according to its respective species. So CrOH3 produces CrO3 2 minus. Okay, and this is an oxidation step. Meanwhile, for the next step is IO3 minus produces I minus, okay, which is the reduction step. The same way that you can do is you're gonna, if you want to prove whether which one is oxidation, which one is reduction, you need to find the oxidation number of the Cr and see whether it's increased in oxidation number or not. Okay, and same goes to here. So I will try to prove it here. For example, the iodide here, IO3 minus. So the oxidation number of iodine, I need to figure out, which I put X. 3 oxygen refers to 3 minus 2. And then the charge of the polyatomic ion is negative 1. And hence, the charge of the oxidation number of iodine going to be plus 5. And hence, I can say that it's equal to 5 plus. So I know that the oxidation number 5 plus into minus 1 is has decreased in oxidation number. So I know that it is a reduction. When one equation is reduction, the other equation automatically going to be oxidation. And you can prove it by yourself. Okay? Once we settle with divide, we're going to focus on balance. So the same thing as before. We need to balance the oxygen atom by adding H2O. And then we need to balance the hydrogen by adding H+. In order to balance the charge, we need to add electron to the side with a greater overall positive charge. So as what you can see here, Cr and Cr, okay, have 1, Cr have 1, okay. Oxygen, we have 3 on this side, okay. Oxygen here, we also have 3. But the hydrogen here will have 3, but then this one, hydrogen is 0. So in order to add hydrogen, we need to add H+. How many of those? We need to add, yes, 3H+, because we have 3H here. So we're going to add 3H+. Okay, so the number of atoms at both sides are equal. Now we're going to check the charge. So on the left hand side, the charge is 0, okay, because there is no charge. In here, you have negative 2 and 3 plus H, 3 times positive 1, they're going to be plus 3. So overall, it has a charge of plus 1. So it is not balanced yet, and hence you need to add electron to the side with a greater positive, overall positive charge. So we need to add 1 electron. Okay, so we add 1 electron, and hence the overall charge is going to be 0. So the left hand side and the right hand side has an equal charge. Okay, now we're going to do the reduction part. So IO3 minus and I minus. So I1 I is equal to 1. Oxygen have 3 oxygen here. We doesn't have any, so we need to add. When we are balancing oxygen, we need to add H2O. So we're gonna add 3 mole of H2O. Okay, so if the oxygen here gonna be 3. Okay, but now the hydrogen on the product side gonna be 6 because it's 3H2. And hence on the reactant side, the H here you need to add 6H as well. So you need to add 6H plus. Okay, looking at the statement here, hydrogen by adding H plus. Okay, so now the both left hand side and the right hand side has the same number of atom. How about the charge? So let's do the charge here. So we have 6 plus minus 1. So we have overall plus 5. Here we have negative 1. Okay, so in order to balance the charge, we need to add electron to the side with a greater overall positive charge. So plus 5, we're going to add 6 electron. Okay, so plus 5 minus 6, overall it's going to be negative 1. So negative 1 and negative 1 is balanced. Okay, so now this equation and this equation will then be combined in this next step. Okay, so D done, B done. Now we're going to focus on C. So we need to combine the half equation and ensure that the two equations have the same number of electrons. Simplify the same as by cancelling the species appearing on both sides of the equation. So the similar thing as what you have learned in acidic. Okay, so this is equation number 1 and this one is equation number 2. So as what you can see here, the number of electron is not the same. So equation number 1, you need to multiply by 6. So the overall equation is multiplied by 6. So you have 6CrOH3 produces 6CrO32 minus plus 18H plus 6 electron. Okay, so when the same number of electron, the product side can cancel out the electron on the reactant side. Okay, so when you combine them, you can also see that the 18H plus here can also cancel out the 6H plus. 18 minus 6, you're going to have 12H plus balance. So in this case, this one will be removed. 18H plus tolak 6H plus. So baki 12H plus. So on your leftover, you have 6CrOH3 and IO3 minus as the reactant part. And then for the product side, we have 6CrO3 minus, and then we have I minus, we have 12H plus, and then we have 3H2O. So the product side is here. Okay, so you just copy back. And the sequence doesn't matter. So you can put 12H plus at the front or at the back. Okay, as long as the number is the same. Okay, so we have done divide, balance, and combine. However, when we are talking about basic, we have another step, which is the OH minus, DBCO. Okay, so note for basic medium, the hydroxide ion are added after we complete the step number 3. So now let us do step number 4. So in basic medium, the number of hydroxide ion added must be equal to the number of hydrogen ion. Okay, and the hydroxide ion must be added on both sides. Okay, so this is the equation that we have made just now, but now we're going to add OH minus. Okay, OH minus need to be added on both sides, the left hand side as well as the right hand side. But how many should we add? We need to look at the number of the H plus ion. So if the number of the H plus ion is 12, so we're going to add 12 OH minus. Same goes on the left hand side. Okay, so when you do this, which is the red color here, you means that you already add up. And as what you can see, you have 12H plus and 12OH minus. So these and these can combine together. H plus and OH minus can combine together in order to form HOH, where HOH here refer to water, H2O. Okay, and as the result of this combination, you have 12H2O. And 12H2O, when you add up with 3H2O, 12 plus 3, you're going to have 15H2O overall. So what you're going to get is you're going to get 15H2O because of this combination, and the others you just copy back again. Right? And you can also double check the charge. Okay, if you were to double check the charge, 6 times 2 minus is equal to negative 12 minus 1. So it's going to be negative 13. On the left hand side, we have 0 here, we have negative 1 here, plus 12 minus here. So it's going to be 12, negative 12. So overall, we're going to get negative 13. So the charge negative 13 on the left hand side is the same as the charge of negative 13 on the right hand side. So you know that the redox equation at the basic medium is balanced. Okay, and as for the summary, remember in acidic medium, we're going to do divide, balance, and combine. In basic medium, you're going to have divide, balance, combine with an additional step, O. So it's going to be DBCO. Alright, so I think that's all for today's video. See you again some other time. Bye!